Hello, this is the generally approachable Sudoku for the 17th of March 2024. It is Atlantic by Bill Murphy featuring thermometers. So yeah, let's take a look at the rules. Normal Sudoku rules apply. So place the digits 1 to 9 in every row, every column, and every 3x3 box. I think those exact 3 sets of 1 to 9 are my default now. Anyway, digits along thermometers must increase from the bulb to the tip. So take this thermometer for example. The sequence of digits here form an increasing sequence. So basically, something like this would be valid, where every digit is greater than the previous one. They can increase by any amount at any time. So yes, as long as every digit is greater than the previous one, that is fine. And those are all the rules. So yeah, with that, let's just begin solving. Okay, so not a lot of digits here, but I do notice that we have what appears to be symmetry going on right now. I can't be entirely sure though, because this thermometer is very suspicious. Anyway, let's see, how do we begin? Oh really? I mean, those digits are only 5 long, right? This one is 6 long. And digits that are 6 long have like what, 4 options per cell. I don't think at this point I need to explain why, because I don't think I'll use that fact. Hopefully not. But maybe if it comes to it, we'll have to use it. I guess I do notice that all of these cannot be... Oh yes, it's this thermometer. I was telling you it was very suspicious, and in fact it is. Because that digit is bounded lower, and that digit is bounded quite high. So because of the 9 and 8, that digit is at most a 7. And because of 1 and 2, that digit is at most a 3. And between 3 and 7, you have exactly 4, 5, and 6, which fill up 3 digits. So in fact, your thermometer is forced to be a 3, 4, 5, 6, 7. So yeah, I just had to figure that out. Alright, I guess we can continue. Yeah, alright. What next? Okay. I don't know where to go next. There's actually a lot less information than I would have expected. But maybe I'm just not seeing it, you know? Like maybe those digits being less than 9 have some significance. But I don't know, they transfer over to those cells, which could be anything at the moment. Except it can't be 5. I mean, if this digit is at least a 2, right? I guess. If this was as high as possible, 9, 8, 7, 6, 5, 4, this is at most a 4. I guess for similar reasons as at most, at least a 6. It's at least a 6. If this was a 5. So should I start marking? Yeah, I guess I'll start marking candidates for this then. And we know this is at most a 6 because if this is a 1 and you go up by 1 each time, you will have to reach 6 at the very least. So this is at least 6. And therefore it's always going to be 6 and above, but it can't be 9, so it's 6 to 8. This one similarly, if it was an 8, by going down 1 every time, you'll reach eventually a value of 3 here. So this is at most a 3. And then everything in the middle just fills itself like this. I mean, there's also an explanation as to why those digits are those digits. But we could probably not talk about that. I mean, okay. The minimum is 1 to 6, which gives us our first set of digits, right? The maximum is 8 back down to 3, which gives us the last digits in each of this set. And therefore, for each of the digits that we put in, that cell could be between the digit we put first and the digit we put last. So because we put in 3 and 5 first, 4 is also a valid value we can place in here. And now I can remove 3 from that cell. And so this cell can no longer be 4 because nothing here is less than 4. And we can continue that up to do that. I guess. It's not very useful. I mean, the 6 over here also helps with that. So that is now just a 7. So that's just an 8. Interesting. And this 4 means that can no longer be 4. Whoa, no colors please. So this can't be 3, because this can't be anywhere that's lower than 3. Okay, let's keep going. This one we can do the same thing. We know there's at least a 2, so we can do all of that. And because this is at most a 9, by going back down 1 every single time, we reach a maximum value of 4, and everything in between would be valid. And so now we can do more deductions. This 4, for example, removes 4 from that cell. This 6 removes 6 from that cell. So this can no longer be 7. What did I do here that allowed me to... This, right, this 7. This can no longer be 7. So this cannot be 6. Meaning this cannot be 5. It must just be a 3. Therefore this must be less than 3, which is a 2. I guess maybe that helps with this then. Because it's now at least a 4, right? If you went with the 4 option, the least you could do is put an 8 up here. And if you went with the highest option, this being a 9, then the most you could do would be to put a 5 here. So I'm not explaining this very well. But yeah, you get a lot of patterns. This 7 is now making this a 6, which makes this a 5, and therefore that's a 4. All of this just resolves the one beside it. 8, 9 pair actually tells us that's a 7. That's an 8. This must be greater than 8, so that's a 9, that's an 8. Okay, yeah, this is very, very messy, so hopefully I'm not butchering this. Trying to, you know, figure stuff out. This is at most a 6. We can do the exact same thing, right? 6, 5, 4, 3, 2 is the maximum we can have. The lowest we can have if we started with 1 here is 1, 2, 3, 4, and 5. Now we can do a bunch of elimination. This 4 means that's a 5, which means that's a 6. 3 means that's a 4. 1, 2 pair means that's 3. That's 2. This 2 means that's 1. That's 2. 5 means that's a 6. 4 means that's a 5. And we're basically done with all the thermals. We just have regular Sudoku now. 1 and 9 has to be outside. Oh, sorry, in the column. Those digits to finish the box are therefore 3 and 7. Therefore, those digits are 4 and 6. 4 or 6. And this 7 resolves the 3, 7 pair. And the 1, 9 remains unresolved. We actually have this as well. This is 3 and 7 as well. Wow, this 3 resolves that. 7, 3. Cool. What else do we have? 3 in this box. It has to be up here. Therefore, in this box now, those can be 3, so 3 goes there. 3 in this box is therefore over here. And therefore, in this box, 3 would be here. That's all the 3s. Can probably do the same thing with 7s. So 7s, for example, in this box have to be up here. Therefore, in this box has to be here. Therefore, in this box, because of this 7, has to be here. And therefore, in this box has to be here, which gives us all the 7s. Nice. Okay, what else? Those digits form a triple, which have to be 2, 8, 5, 2, 5, 8. Could probably resolve that. This can be 8. That can be 2, that can be 5. Alright, very helpful. Chocolate teapot. We love those. Alright, this is also 2, 5, 8, I think. So this digit can be 2, that digit can be 8, that digit can be 5 as expected. But now I guess we do have some pairs over here, which is quite useful. Because the remaining digits do form a triple. Those have to be 1, 9, and 6. And in fact now those digits can be 9, the ones I highlighted, which means 9 must go here. 1 must go there. Those digits are therefore 4 and 9 to finish the box. Which actually resolve this pair over here. This must be 4, that must be 6. Oh, this 2 also resolved this. I never actually saw that. But I suppose now that we're here, it fixes itself. 4, 9, and 1, 6 pair I think cannot be resolved yet if I use my eyes properly, which I haven't been doing. Alright, those digits are 2, 6, and 9, which I also don't think are resolvable, except that maybe they are, because the 2's here remove 2 from those cells. So 2 goes there. That forms a triple of 1, 6, 9, I believe. Nice. And now that digit can no longer be 6. That digit could be anything. Cool, could probably do that here as well. Those digits are 1, 4, 8. The 8's over here, I mean those can't be 8, so 8 goes there. This has to be 1 and 4. Which means those digits, to form a triple, are 1, 4, and 9. That digit can't be a 4. Cool, that could be anything, I think. Cool. Probably have to do more Sudoku. Like 4s in this box. Because of those 4s, come in those cells, so 4 must go there. This digit is therefore a 6, because 6 can't be in those cells, has to go there. And that forms triples all over the place. This has to be 189. 8 can't be there, so 8 must be here. This is either 1 or 9 as well. That digit is therefore a 2 to finish the box. And therefore a triple over here would be 1, 4, and 5. This can't be 4 or 5, so that's 1, which resolves everything. 4, 1, 9, 1. 1 means that it has to be, well, 4 also means that it has to be 5. 1, 9 means that's 4. 1 here resolves this 1, 6 pair, which resolves the 6, 9 pair, which continues all the way over here. This must not be a 6 to finish the row. 4 here resolves this 4, 9 pair. And we're almost done. Those two digits are 8 and 9. That is resolvable. Those digits are 1 and 2. We can fix that. And those last two digits are 5 and 9, which solves the puzzle in 10 minutes 48 seconds. Nice. Well, that wasn't the fastest, but it really wasn't very trivial thermal logic, I guess. So that's cool. I don't know if gas is ramping up. It certainly feels like puzzles are getting slightly harder over time. There are some outliers that are either super simple or super hard, but I think that just comes naturally because you know, difficulty is always subjective. It's like the setter probably doesn't want something to be that difficult, but because of the way they think about a puzzle, you know, they would assume some deductions to be trivial while others could spend like a long time trying to find them, which is actually what happens a lot when I solve regular puzzles as well. But alright, with that, I hope you enjoyed this video. I'll see you guys next time. Bye bye.